Good morning, all. How y'all doing out there? I hope you're having a good day. I hope you're having a good life. We're not doing too bad here. But here we have a Lenze type EVS 9325-ES. And we're going to test the digital outputs. And I'll show you how we can do that. We apply 380 volts AC 3-phase to L1, L2, and L3. I heard the pre-charge relay energized. That's a good sign. Let's go see what we have here on the LECOM. Okay, we have no alarms on the LECOM. There's a red LED that blinks on the LECOM. The LECOM is what we use to communicate to the laptop or the laptop to the drive. It's RS-232. So let's get closer to the laptop and we will start up the Global Drive Easy program. Let's click on the Global Drive Easy icon right here. Okay, this we can ignore. Let's just cancel out of here. Let's go up here to this icon, and this is our connection icon. Turn that on. Let's go to Drive. Let's drop that menu down and go to Find. Now here, it's going to search for drives. Let's click Search. There, it found it. That's a good sign. Communications is good. And right now, it's bringing in the parameters from the drive. This will take just a little bit of time. I'm going to go get me a cup of coffee while it's downloading. Okay, we're almost there. Yes, we're here. Okay, we have no faults. I have my test resolver connected to the X7 DB9F connector. If I did not have a resolver connected, we would have SD2 trip right here instead of no fail. Now this is the control inhibit. That means we don't have 24 volts, external 24 volts applied to a terminal 28 on that drive, and the ground of that 24 volt power supply connected to terminal 39. We're going to go over here and look at the digital output. Let's see, here's terminal I/O. Let's drop that down. And here's digital output. Now right now, I have to get you closer. I don't know if you can see it, but digital out 1's polarity is active high, and digital out 1 is set to fixed 1. Now this is where we're going to use that parameter and change all of these to fixed 1 and active high. Fixed 1 means that that output is always on. There's a fixed 0 parameter value. That means that that output would always be off. So let's leave digital out 1 as fixed 1. Now this is digital out 2 polarity. It's active low. We're going to change it to active high. Click on that parameter and select high, active high, and click OK. And it is set to analog comparison 1 out. We're going to change that to fixed 1 parameter. Click on it. Here's our list that we can change that value to. Now fixed 0 is at 1000, a value of 1000. Fixed 1 is a value of 1001. Let's click on that. Whoops. Fixed 1, click OK. Now that output will always be high. Here, digital out 3 is high, active high, and it is set to digital control ready. Or that might be device control ready. Not sure which. Let's go down to 1001. Select fixed 1, click OK. And here, digital out 4 is active high, and it is set to digital delay 1 out. Let's go up here to 1001. And set it to fixed 1. Now, all of the outputs, and we'll go over here in just a second. I want to get you closer over here so you can see what we've got it set up to. But we'll go measure the outputs with our meter, and they all should be at well, I don't know, 22, 24 volts DC out. We'll get there. Okay, I'm going to clip terminal 39 to our voltmeter ground probe. There we go. Let's find a good place to set this without getting all tangled up. Okay, there's terminal 39. I got a wire connected there. Let's set our meter to volts. I'll turn this light on. Might be able to see it a little bit better. Yes, okay. Now here's the A1 terminal. That's digital out 1, and it is 26.2 volts DC. That's high. Here's digital out 2 on the A2 terminal. It's also high, 26.2 volts DC. Here's digital out 3 on the A3 terminal. It's 26.2 volts DC. And here's the last one. Digital out 4 on the A4 terminal. 26.2 volts DC. That's good. Okay, you can see with that parameter, fixed 1, that the outputs are all turned on. Now we're going to go set those to fixed 0, and when we measure the A1, A2, A3, A4 terminals, digital 1, digital 2, digital 3, digital 4 output, they should all be low. Let's get back over in front of the laptop and we'll change those from fixed 1 to fixed 0. All right, let's go back up here to digital out 1, and it's set to fixed 1. Let's go up. We'll set it to fixed 0. Click on OK. Let's go to digital out 2. change it from fixed 1 to fixed 0. Let's go to digital out 3. We'll change it from fixed 1 to fixed 0. Last one, digital out 4. Change it to fixed 0. There we go. Now when we measure those outputs, they should all be low. Let's see what we have now. Here's digital 1 out on the A1 terminal, and we have 22 millivolts. That's a low. Here's digital out 2 on the A2 terminal. Again, we have 22 millivolts, 0.022 volts. Here's digital out 3 on the A3 terminal, 22 millivolts. That's a low. Here's the last one. Digital out 4 on the A4 terminal. That's 22 millivolts. All low. When we set that output to fixed 0. Fixed 0 means the output is off. Fixed 1 means that the output is on. So fixed 1, always on. Fixed 0, always off. Now that's one way y'all can test your outputs. You could do this from the display. Let me show you the display. But it's much easier doing it from the program because you don't have to scroll up and down through the menus of this display. Here's the display of the drive. You could do it with this display. It just takes a little bit longer. The display, here's the part number of the display. It's type, see if I can read it, EM2937. I gotta get my close-up glasses. EMZ937 1BB1A. Right there. That's the keypad display. There we go. One more thing we have to do, we have to make sure that the parameters return to their original. Now up here, parameter C0003, parameter save. If you wanted to retain these parameters, you would click on this, and you have different places where you can save. You can click on ready, save to parameter set 1, save to parameter set 2, save to parameter set 3, save to parameter set 4. Now I'm not going to do it, but if you clicked on OK, these parameters that we just set in the drive would be retained in that drive. But I don't want to do that, so I'm going to go over here and click cancel. Now all I have to do, since we didn't save the parameters to the drive, all I have to do is power down, and the original parameters will be displayed again. Let me go ahead and power down. Okay, I just removed 380 volts AC 3-phase from L1, L2, and L3. Takes a little bit, but we'll get a message pop up here in a little bit. There we go. It says connection to drive interrupted. Do you want to go online? Now let me reapply that line voltage to the drive. I heard the pre-charge contactor energize. Let's click yes because we want to go back online. Tell you what, let's bring the drive parameters back in. Let's see. Read actual parameters set from the drive. Let's click F7. Okay, we're going to pull the drive parameters back in. Coffee time! It's always a nice time to take a little bit of a break. But after the parameters are loaded back into the drive, all of the digital out should have the original settings that we saw earlier. There we go. Look at that. Digital out 1's polarity is active high. Digital out 1 is fixed 1. Digital out 2's polarity is active low. Digital out 2 is set to analog comparison 1 out. Digital out 3 is active high. And digital out 3 is set to device control ready. Digital out 4's polarity active high. Digital out 4 is set to digital delay 1 out. There we go. As long as you don't save with parameter C0003, the original data is retained in the drive. All right, all. We learned something today, didn't we? You can check your digital outputs. Now in the future, not sure when, I'm going to try to figure out the digital inputs and see if we could set the drive up to where we could check the digital inputs. Have to do a little bit of research on how to do that. But here we have learned something very valuable today that may aid you in the future of your troubleshooting ventures. Okay, all. Have you a good day. We'll see you in the next one.